This is the Genius 215 quadcopter. There's gonna be a build video for this. It's not as good as my other build videos. You have to read a lot of annotations to really keep up, because this board was a little bit more difficult to program, the F4 board, than my other flight boards. I don't know why. I think something's wrong with my computer. I've had another friend who flashed like 6 of them in a row, didn't have any problems. Something's wrong with my computer. Anyway, Genius 215, the 4-in-1 ESC, 2600 kV motors, the 5042 props. This thing makes for a clean build. Get your soldering skills ready. There's not a whole lot compared to the 210, but there are some. So anyway, hope your soldering skills are up to par. Here we go, let's get this thing built. So here are all the pieces that come with the kit. Of course, you get the Genius 215 frame, you get a 30 amp 4-in-1 ESC, and this has enough spacers that you should not have to have extra spacers for this build. It comes with an F4 board. This is the same one that comes in the X210 Pro kit, and you also get 2600 kV motors. These are the red racer stars like this, and they're the 2205, and they should be 2600 kV, which maybe it was right there. Yeah, 2600 kV motors. Now, there have been some people that have asked, is 2300 fast enough? Well, it depends what you mean fast enough. But these 2600 kV motors, I've been running 4-cell batteries with 5-inch tri-blade props on here. And the first time I flew it, they got kind of warm, but after that, they never really got much warmer. And so I'm not scared of running 5-inch props on 2600 kV motors. So for this build though, it should be a lot faster simply because of this ESC being all-in-one. You don't have to do as much soldering, it should be a little faster. Oh yeah, it also comes with these Racer Star props. They look a little bit like the, what are they, Racecraft props or something. Came with these, so let's get started on this build and see how this thing flies. Each motor comes with a short screw and a long screw. The short one is used when your arms are 3 millimeters thick. However, for the Genius 215, they're 4 millimeters thick, so we want to use these longer screws. Now, when you attach the motors onto your arms, you just want to use the drip of lock thread or a thread lock on this, and that should be enough. Now, if you want to do the soft mount thing that everybody is kind of gung-ho for, you can take some electrical tape and put about 2 or 3 layers of electrical tape on here and then cut the holes out for the screws to go through, and that'll be, you know, a nice soft mount, but I'm not going to do that. Here, I'm just going to put a little drip on there of thread locker like that. Go ahead and slide it through the arm, and it doesn't matter at this point which arm you screw the motor to, because none of them are attached yet. But just put a little bit on there and go ahead and thread it in. And the main thing to make sure is that you have the wires running down the arm like this. You don't want the wires running off the side of the arm like this, otherwise it'll look kind of goofy when you get down a little bit later in the build process. But go ahead and get all the motors attached on, and you shouldn't have any problems getting the screws into this because all the holes are cut pretty far apart. And anyway, once you get that done, we'll move on to the next part. On these screws here, I'm taking this wrench and I'm just kind of twisting it until it gets snug, and then I'm just giving it a little bit more twist, maybe about 1/8 of a turn more, just to make sure they stay snug. So anyway, there's all 4 of these. Now with this 4-in-1 ESC, all these wires are going to be a little short to reach the 4-in-1 ESC, so we're going to have to extend each of the wires out a little bit. So these wires are about 20 gauge, and it just so happens I have some extra 20 gauge wire here, and let's see. This extra wire is not included with the kit, by the way. But yeah, you can tell they're about the same size. So this is 20 gauge. If you have some 18, it'd probably be okay. I wouldn't use 16 because it's going to be pretty heavy for, you know, and thick for soldering onto the ESC pads. So the next thing I'm going to do is I'm going to go ahead and get the bottom plates put together with the arms in place. That way I can make sure that the length of wire that I add onto here is going to be enough to actually reach all the solder points on the 4-in-1 ESC. The kit comes with 3 different sizes of screws, these longer ones, medium, and shorter ones. And what we're going to do, take this bottom plate and we're going to slide the longer one in on the outside and the medium one in on the inner hole. Then we're going to take the motor with the red lock nut on the front, and we're going to put these up, make sure they get to the front right and the back left. And the reason you want to do that is because of the way that the motors are set up to spin. that when the propellers hit something, instead of spinning this nut loose, they'll actually try to lock it down tighter. And that's good for crashing a lot because your props won't spin off. Now here's the main plate and this little side back here with the bumps in it. This is the rear of the plate. So we want to make sure we put the red lock nut motors on the front right. So there it is. You don't have a lot hanging through there. But then these little things are going to go on here, and that's what's going to hold the arms down. And we're going to put the long side on the longer screw, and the idea is that that long screw is actually going to stick through the top of this so that we have something to mount the 4-in-1 ESC to. And it should look like this when you're finished, where you have a lot of the thread hanging through the top one and not hardly anything into the bottom one. But that's how you want it to look, and I'm going to go ahead and get the other 4 motors on. And like I said before, make sure you pay attention. You want the black one on the ones with the black washer on here on the front left and the back right, and the red ones on the front right and back left. Don't get them backward, please. It'll be a pain later. On the shorter screws that go into the arms, I'm going to put a drop of this Loctite on there because I don't ever check the bottom of the frame to see if the screws are loose. Maybe I should, but I don't. So I'm going to put this little bit of thread locker on there, and then I'm going to run it up through here and into the metal piece, and that'll help just keep that screw in there and not let it hopefully come loose, because these arms, normally these arms would touch each other inside the frame, and that would help give it a little bit more rigidity between the arms. They can kind of play off each other's strengths being screwed into the plate. But on this frame, those arms don't touch each other, so that's kind of a weakness of this frame. But with the Loctite on here, they should lock down tight enough that you shouldn't have any problems with the screws working themselves loose. Here I have all the motors installed and all the arms attached, and here I have the 30 amp 4-in-1 ESC. Now we need to pay attention to this because this says motor 1, motor 2, motor 3, motor 4. Okay, so we know if we're going to run Betaflight, which is what I want to install, this is motor 1, 2, 3, 4. So I'm going to flip this upside down, and here's 1, 2, and then 3 and 4 are going to actually be backward. So we're going to have to run this wire back to this one, and this wire up to this one. And I say wire, but I really mean 3. So this is going to sit on here. I'm going to scrape off a little bit of the shrink wrap so that I can access the holes. But it's going to sit on here like this with the wire coming out the side. Now, if you don't want the wire coming out the side, you can probably unsolder this and resolder it on any way you want so they come out the back or whatever. So do that, do as you wish, and I'm going to go ahead and get this thing mounted on here. With the 3-in-1 ESC attached, this first wire will probably reach here, and you'll be able to solder it on. The problem is when you try to push this down to the arm, it's going to be tight, and if anything pushes on this, it's probably going to rip it off of the ESC pad. So we don't want to do that. Well, because I don't want to use up all my black wire and all my black shrink wrap, I'm going to use 3 black wires on the black nuts and 3 red wires on the red nuts. And I'm going to go ahead and I'm going to solder these straight across onto these ESCs. Like I said, this 3 and 4 on this side here, the left side, are both going to be backward. But we'll take care of that when we run the wires from the ESC up to the flight board. We'll just reverse the 2 wires there. That way all the wiring down here below can still look nice. So the next thing I'm going to do is go ahead and get these wires stripped off and tinned up a little bit and get them soldered onto here. And I'm going to use a little bit of shrink wrap that's also not included in the kit, along with this 28 gauge wire that's not included in the kit, and get these things ready to solder onto these pads. There, those are all 3 soldered on. Now I'm going to use some of this shrink wrap and cover those up and shrink it. Now, like I said, the reason I don't want to use all black is because then I'll have uneven amounts or awkwardly uneven amounts of wire and shrink wrap. So there, the first 3 are done. Now there's only 9 more left to do. All the wires now have been extended with about 3 centimeters of extra wire. It's about like 1.5 inches. So the next thing we're going to do is to solder up and tin up these ESC connections along here. All those are tinned up. Now the next thing to do is to connect the ESC wires. Now before I do that, what I'm going to do is I'm going to go ahead and I'm going to run these wires along the arm, and I'm going to put a piece of electrical tape around the wires to help hold them in place. One other tip, before you tape these down, take an extra propeller you have, or maybe a broken one, chop off a little bit, about like this much, and what we're going to do with this is lay it down over top of your ESC wires. Get those laid down nice and pretty, lay this down on top of it, and we're going to tape this down onto the arm along with the ESC wires. And what it's going to do, it's going to give a little bit of protection so that when you crash, if your propeller bends and it actually comes down and hits these ESC wires, well, instead of tearing up your wires and causing you not to be able to fly the rest of the day, it's just going to hit that extra propeller that's on there and hopefully save your ESC wires. So maybe I could have made that tape a little bit longer. But there we go, just like that. And that gives a little bit of protection, like I said, for when this propeller comes in here and it bends down and it crash and starts whacking on this, it'll hit that propeller instead of tearing up your ESC wires. That's a little tip I picked up from Bulldogger. Here I have all the motor wires taped down. Now hopefully when you ran these things, you kept these wires fairly straight. It's not a big deal if you didn't, but don't worry about it. But if you did, it's going to make your life a little bit easier later. We don't have to reverse the motors. Now, with these black wires, we're going to take these wires, and they come out of here just like in this order, out of the motor itself, and we're going to solder them onto these little pins here in the same order. So this far right one will connect to the right one, the middle one to the middle, left to the left. And these three are for the motor up here, and these three are for the motor back here. Now, when I solder these on, let me get these other ones out of the way. I want to take these and I want to make it look nice, because that's the whole point of having it like this. Now we want to have it look nice, and we want to put these on here and solder them onto there, and we're going to cut them just the right length so that way, like I said, they look nice. There I have my first one done. Now, looking back at this, you would have been better served to have cut these wires back about 1 centimeter. That way it'd move all this stuff back, and you still have enough room to run your ESC wires, because I ended up cutting off about 1 centimeter off of each of these. Well, lesson learned. Hopefully you do it, make it look a little better than me. Now on the motors with the red lock nut on here, you're actually going to want to cross 2 of these wires. It doesn't matter which 2, it's just a matter of crossing 2 of them. And what that's going to do, it's going to tell this motor to actually spin counterclockwise instead of clockwise. If you bring them straight out, they spin clockwise. If you cross 2 of them, then they get clockwise. And like I said, it doesn't matter which 2, it's just a matter of taking 2 of them and crossing them and calling it good. I have all the motor wires soldered on now, and if I had cut those wires back about 1 centimeter and then added the 3 centimeters of wire, it would have been a lot better, especially because it kept trying to bend pretty much where I had just soldered the wires together. Okay, well, do yours better, and it'll look a lot better and a lot cleaner. Next thing we're going to do is get this F4 board on. Now, the F4 board should be able to fit on here, and we should have enough wire or enough screws sticking through here that we can get the spacers onto here. Now your flight board should have come, your ESC should have come with some spacers, if I can find them, and we're going to put those on, and then the F4 board is going to sit on top of those. These are the spacers that came with the 4-in-1 ESC. I'm not going to use those. Instead, I'm going to use these that came with the frame itself, because they're just a little bit shorter. So I'm going to pull these out and see, hopefully I got enough threads to get them on. We'll see. A little change of strategy here. This is the long screw. This is 20 millimeters long. There's not quite enough threads hanging out the top for this last spacer to catch on there. So I'm going to do a little change of strategy. I'm going to take one of these medium-sized screws that I have left. It is a 10 millimeter screw actually, and I'm going to put just a little bit of Loctite on it, and I'm going to put it into this hole here and have it just lock into the little metal spacer on here, and then I'm going to put the nylon spacer on the top and upside down like this, and there we go. Look at that. Now it looks perfect. Now it's got to get the Allen key on here. Now what this is going to do is it's going to kind of mess up the layout a little bit, and by layout I really mean they didn't give you 10 of these or enough of these 10 millimeter threaded screws to replace all 4 of these. So I'm going to look through my little collection and find a couple extra 10mm screws to put in here. Hopefully yours has enough threads hanging through that you can do that. But I'm going to go ahead and I'm going to replace all the other 3 of these long screws with some 10mm screws, and then put these spacers upside down and then move on to the next step. Lucky me, I found 2 10mm screws in my little box of extra screws that I have not been throwing away. If you have extra screws, put them in something like this and don't throw them away. You might need them later. I have all those 10mm screws in place and all the nylon spacers put in inside there upside down. Now if you look real close on here, if it'll focus, this ESC that comes in here, the 4-in-1 ESC, has a 5-volt output and it's 3 amps. There it is, kind of right down here by my finger. It's a 5-volt output, and that means that these wires here, these black and red one, are outputting 5 volts. So the big thing about that is what's going to actually power our flight board. Now on here we want to make sure that we have the signal wires back here for the ESCs, which is this side of the board. Here's the USB port. We want this side of the board to the back. So we're going to put it on here like this. This is the back of the quad where it has the little grooves here. We're going to put this here and we're going to cut these wires off and solder them right up to the flight board right there. This thing is going to be an extremely clean build because we just don't have many wires on here. Now there are some other wires on here that we're going to hook up also, including the VBAT, so we can so that the flight board will know what the voltage of the battery is on that's connected in here to the 4-in-1 ESC. Before we go any further, I'm going to take these wires, these power wires, and I'm going to push them back through the back of this board here, so that way they are coming out the back instead of out of the middle or out the side. And I'm going to take a XT60 connector, solder it onto this, and I'm going to zip tie it down to this frame here. That way it'll stay back out of the way, and when you're trying to plug and unplug, the zip tie will hold the XT60 here, which will hold the battery cable out of your propellers, which is what we really want to do. So I'm going to get a couple lead wires for the VBAT, and we're going to solder it right on top of these wires here, because these are going to be the incoming battery voltage. So we can tap right off of there. If you want to do it extra clean, you can take these wires and unsolder them and solder them onto the bottom side, and that way you want to have this little over-under look here like this if you wanted to. But I'm not going to do that unless they come off, then maybe I will. But I'm going to go ahead and try to solder on the VBAT wires onto those wires there. To connect this VBAT, all we're going to do is connect the red wire. We don't need to connect the black, because the black is going to be connected up to the ground up above, which is connected to here, and this wire is actually connected to the black wire here, which I'm holding here with my left hand. And if I touch this black one, you can see it's already being grounded. So we don't need to actually provide a ground wire for the VBAT. All we need is just a single wire, and it doesn't matter what color, but if you have red, it's kind of cool, because then you know red always carries a voltage. And so I'm going to solder this wire onto the red connection right here along with this power wire here, and hopefully I don't pull it off there. If we do, I'll figure out a way to get it to stay. There we go. So on here, these are going to be for the buzzer. This one here is going to be the ground. I'm just going to tin these up so I can get it to stick a little bit. And then this one here is going to be for the positive side of the buzzer. While I'm tinning these up, I'm also going to go ahead and tin up the one for the VBAT, and that's going to be this very back pin right here. Get it soldered up. There we go. Like I said, that's where the VBAT's going to go. So we got the buzzer and VBAT. Buzzer is soldered in place. So with the buzzer soldered in place and the VBAT wire here soldered to the ESC, you need to take out the spacers and the nylon screws that came with your 4-in-1 ESC, and we want 4 of these little screws out of here. Now these screws are actually going to be too long to fit into these shorter spacers. So I'm going to take a pair of snips and I'm just going to cut off about 1/3 of them. About like this much of the screw. Just snip it off, and hopefully this will still go in there. Clean it up a little bit maybe. There we go. And then for the buzzer, I'm going to have it bend underneath the flight board like this, and I'm going to have it lay down right there. So that way I still have the buzzer, but it's not going to be in a place where it can move around or potentially get into my props, which is what I absolutely do not want to happen. So I'm going to try to take this chopped off screw here and see if I can get it down into this flight board. Success. Alright, 1 screw down, 3 more to go. I'm going to chop them off, like I said. Chop off a little less than a third, maybe about a quarter of it, and then put them in there. I think they only need just about 1 or 2 millimeters off, because I was trying a little bit ago and they were bottoming out and it wasn't getting tight. So this one here is a little bit longer than the other one. We'll give it a try too. That's near perfect. And just so for a reference, you can see this is about how much I'm cutting off. It's just a few threads off of it. But it's enough that this flight board is now in there tight and it's not moving around. If you use the full length, it's not going to work. You're going to be the bolts are going to be too long to hold the flight board down tight. All right, there it is. All right, now I'm going to go ahead and take this V-bout wire and get it soldered down here. I only need it to be just about that long, so that should be plenty of length there. And chop this off. This is a little bit of 20 gauge wire that I had. If you have old servo leads laying around, they'll work real well too. This wire is not going to carry hardly any amps at all because it's just reading the voltage off the battery. So you're talking way less than even 1 amp or even a quarter of an amp. It's going to be just very little. Got it kind of hanging on the side, but it's good enough. It's going to hold. It's not touching anything else, so it should be fine. If you want to try to use a little bit thinner wire like this, you can actually dip it down in there. This is actually 18 or maybe 16 gauge wire, so it's a little bit too big to fit down through those holes. But this 20 gauge wire that I used for the battery or the buzzer worked perfectly. So on this part of the flight board, these 3 pins here are for your S-bus or your PPM receiver. This is where the signal wire goes. Your positive wire goes here in the middle and your ground wire is going to go here. Like I said, these are for your S-bus or PPM receiver. Then we're going to use signal wires on channel 1, 2, 3, and 4. And this is where the signal wires are up here on this row. This is the positive wires. We're not going to use those. These are the ground wires. We're not going to use these. We don't want these things to roll over and touch each other or roll over and touch here. That would be bad. But we're going to use signals or channels 1, 2, 3, and 4. And we've got to remember that 1 and 2 are connected. You know, back here, this is ESC1. This up here is ESC2. This is 3 and 4, but the ESC calls this number 4 here, and this one up here in the front it calls 3. So we need to solder on 1, 2 here, and then 3 and 4 we're going to reverse them here, and that'll take care of the ESC having them backward. But it should be fine. And because this the 4-in-1 ESC outputs 5 volts, we're going to take these little positive and ground wires here, the 2 red and black ones, and we're going to solder them on to ESC4. Why ESC4? Because it's right here and it's real close. Technically, you can attach them onto any of these positive and negatives you want, because all the positives are connected together, all the negatives are connected together. So what's going to happen is 5 volts is going to come out of this, come into here, power the flight board. It's also going to run over here to your receiver and power your receiver off of 5 volts. If you have a 3-volt receiver, don't plug it in here because this is going to be outputting 5 volts. Alright, so they're all tinned up now. The next thing to do is to start connecting these wires. Now I don't want these wires to be too short, but I don't want them to be too long either because I'm trying to keep this build kind of clean. So I'm going to guess they're all going to be about this long or so. Yeah, that'll reach all of them. So I'm going to go ahead and cut these all off right here. If I pull this up tight, you can kind of see I'm going to cut it right up here. You probably can cut them shorter if you're daring. Well, I'm going to cut them right there. I got to strip off these wires just a little bit and solder them into place. There's no good order to do these in except for whatever makes it easier for you to solder. This little plastic piece is going to plug in just like this. So the wires come up here and they bend over like this. And this on here, the orange is channel 1, then this one's 2, 3, 4. 4 is closest out here to the positive and negative wires. So we're going to solder those on straight like this onto channels 1 to 4. We're also going to solder on the ground and the positive. But like I said, 4 is over here on the left. It goes 4, 3, 2, 1. So don't get them backward. Your quad will spin all over the place when you put it on the ground, and it'll be kind of funny for everybody except for you. Okay, that was intense getting it in there, but I think it did it. So the wires are not coming out perfectly, but that'll be okay. It'll still look real good when it gets connected. It'll still make a good connection. So see if we can get this thing to bend around. Also, do not forget to swap out motors 3 and 4, and that would be this green one and the yellow one. So I'm going to heat up this green, pull that out, and that's 4. So I'm going to move yellow over to motor number 4 and put it back in. There we go. 3 and 4 are reversed. And remember, this is 1 over here. The blue is 2. The green is actually 4, but we put it in the motor slot 3 because we reversed the 2 motors. And the yellow is number 3, which is actually in number 4. So we should be good to go. All right, there it is. Look at that clean wire job. There's not a lot of ESC wires running up here. So this is going to look... Wow, it's going to look really clean. Okay, good. I'm glad it's coming along like this. All right, another thing you're going to need that's not included in the kit is you're going to need a battery adapter that's made for the batteries that you're using. In my case, I'm going to be using an XT60. Like I said, I'm going to put it on here and I'm going to zip tie it down to this frame. That way, when I plug it in, the zip tie that holds this down will also keep it from flying into the propellers, and it should make for a lot better flight experience. On here, I took these wires and I pushed them back a little bit like this and pushed them back into the frame, and I lined up this where I thought I wanted it to go. I kind of want these little grooves to go over top of the this part of the XT60 connector, about like this. So I pushed those back a little bit, that way I'd have a little bit of play on it. Now that I cut them off, I'm going to go ahead and pull them back out and solder on this XT60 connector. Now if you solder on this XT60 connector back at the very beginning, it'd probably be a lot easier to get to. The other thing you're going to need are a couple of pieces of shrink wrap or some electrical tape to wrap around the connections once you solder them on, because you're not going to want those things shortened to anything, especially not the carbon fiber frame, because then it shorts out everything on the whole board, and that is bad. Don't do that. So there it is. I got the shrink wrap in place and it looks good. Now I'm going to try to see if I can find a zip tie to hold this down. Also, you can buy little metal adapters that are supposed to be able to, put over top of this, and it's supposed to hold it down in place. If I find one of those, I may put it on. I don't think I have one. But I think for the receiver, what I'm going to do is solder it on right here under these pins, just like it's supposed to be. And I'm just going to lay it up here on top and use some double-sided foam tape to help hold it down to the flight board. Now I'm going to be using an XSR, so there's also one more point on here that we want to solder a wire to, and you can probably use one of these wires that you cut off of your 4-in-1 ESC, but the one that we want to be soldering to is going to be right here. This one, the 4th one down, right there. That's the one we want to solder the telemetry wire to for the XSR. Now if you're not using an XSR, you can use the D4R2 does telemetry, the X4RSB. They're all going to solder onto this pin right here. If you're using a receiver that does not have telemetry, then don't even worry about this part, but that's where I'm going to solder on a wire for the telemetry. So this is the XSR I'm going to be using with my Taranis. On this here, we're going to be using the black wire over here on the end and the red wire, and those are for the positive and negative, the power of the flight board, and this, or the power of the receiver. And this is only a 5-volt receiver, so you want to make sure that 5 volts is coming in. Now if you're using these pins like I told you to on here, that's going to be 5 volts. Also, this white wire is the S-bus wire, and that's what we're going to be hooking up to the flight board also. The yellow and the green wire are not going to be used because they're not part of this. Now for the telemetry, this uses inverted telemetry, or I can't remember if it's inverted or not inverted, but it doesn't use the telemetry outputs that the F4 board does. So because of that, we're going to take this blue wire here that we soldered on for telemetry, and it's actually going to solder on to this little point right there. There's this little black thing here with a point here, and a point here on this side. It's going to go on the single side over here by itself. So I'm going to cut a little flap around here and then solder the wire on, put a little hot glue to hold it in place, and put a piece of black tape on to hold it down, and it should be good to go. There, the S-bus wires are all connected, and like I said, the S-bus goes on the inside, the positive goes in the middle, and ground goes on the outside. In most cases on flight boards, the ground is always on the outside of the board. If there's a question, the ground's on the outside. That's not true over here because you need to look at the wiring diagram to make sure to find the right ground. But whenever you have ESC wires, I should say the ground wire is usually on the outside. So that should be good to go. Now I just need to connect this back up, and I should have telemetry readings coming across when I connect it to my Tyrannus. For these XSR antennas, what I'm going to do is I'm going to use this antenna holder, and I've actually already cut it down. I'm just going to slide this in, and what I'm going to do is I'm going to be attaching, I'm going to tape this down right there, and I'm going to take this first antenna and have it come down here and run along the inside of this arm like that, and I'm going to use a piece of tape and tape it down on back here and back here to help hold it into place, and then do the same thing for this arm over here. And I'm going to put them on the inside of the arms just because I've had real good luck with crashes and not ripping the antennas off when they're actually here, and I don't get any low RSSI warnings, you know, maybe about it being too far away or not getting a good signal. So I'm real confident in putting these on the inside of these arms, and I have a straw for the other side too. I have the antennas in place now. They're both taped right there to the inside. Now before you power this on for the first time and connect your battery, you want to make sure that these two leads here are not shorting together. Let's listen to this. When I touch these together, it beeps. Now if I touch these together and it beeps, I have got problems. Oh good, no beeps, it's going to work. There's not any shorts in here. Now one thing you want to make sure of is that on this rounded side of your XT60 connector, like this, that's where your black should be plugged in, and your red should be on the squared side. If they're backward, don't plug it in. You need to switch them around because it's going to fry everything, and you don't want to do that. And also you need to make sure that your connections up here aren't touching anything up on the top board. But in this case, well, here we go. In this case, I don't have enough, I got big enough spacers in here that it's not going to touch anything. And I think I'm going to end up zip tying this down because I can't find my foam tape. So I think this is about ready to actually power on for the first time and see if anything smokes, which I certainly hope it doesn't. Back here on the back, you might be thinking, can I use the XT60 connector that came with the kit? Well, the answer is no. I mean, look at this thing. It's actually designed for that board, so there's no little grooves inside here that are designed to hold wires. So you could try to hook it onto here, but it's probably not going to hold real well just because there's not a lot of material meant to hold wires. The next thing I'm going to do here is give it a power test. This is a Bonka 1300 4S battery. Normally I try to use a 2S battery just in case. That way it has less chances of blowing something up, but here we go. 4S, and hopefully this thing just beeps and doesn't smoke. Oh good. It's beeping like it's supposed to. I heard the ESCs sing, and you can hear that buzzer going off. Good thing that cover's still on it. It's loud, and that should stop once you flash firmware and bind your Tyrannus or your receiver. Right now you can see it's not bound because it's blinking red. Anyway, next thing to do is to put the new firmware on it and then connect it to the Tyrannus and then give it a test flight. So here we are in Betaflight, and the first thing we're going to do is flash new firmware onto this. So when I click on the firmware flashers tab over here and wait for this thing to load, loading. What's it loading? We want to choose AirBot F4 because that's just what the one we have is. And we want to choose the latest version. In this case, I'm looking at 3.1.6. Go ahead and click on that. I'm going to push Flash on Connect, and I'm going to have this reboot sequence turned on, flash on connect, full chip, and manual baud set to 11.5.200. Then I'm going to come down here and click on the load firmware and wait for it to download. There's downloaded, and now I'm going to hold down the little button beside the little port here. You can kind of see it. It's right here beside there. I'm going to push that button down and then plug it in, and it should go into DFU mode up here. If it doesn't say DFU mode up here, you need to do it again, and just keep doing it again and again until you finally get it to DFU mode. If you get it to DFU mode, then it should be able to flash. Okay, I plugged it in. Now it says DFU mode, so I know it's good. So I'm going to go ahead and I'm going to scroll down here. And it says loaded online. It didn't flash on connect. Oh well. I'm going to click flash firmware right here. Now it says erasing. And hopefully we'll see a little bar go up and start going across. And there it goes. Thank goodness. This part always gets me because I never know if it's going to work or not. It says flashing. Now if this doesn't work, don't unplug your flight board. If you unplug your flight board, it may or may not be able to go back into the DFU mode. So don't unplug it. If you need to flash it again, just click flash firmware again and let it try it again. And right now it still says flashing. It looks like it should be done. I'm gonna go ahead and click flash firmware again. Here we go. Erasing. After flashing this thing nearly a dozen times, it finally took and said successful. I did have to disconnect the USB cable and reconnect it a couple of times, but only after I let it sit on flashing for about a minute. Last time I took it off during the flashing, it wouldn't reconnect, and I don't know what the problem is. But this one finally flashed, so we're ready to move on. All right, here we are in BL Heli. I just clicked on read setup, and it shows the ESCs over here, and hopefully we have 4 of them. If I scroll down, come on, go down. Yep, we got 4. All right, so I'm gonna go ahead and click on Flash All, and right now they're on 16.5. They might already be on the newest one. 16.5, 16.6.5. Okay, we'll go ahead and flash all of these ESCs and let them go at it. All right, here they go. Flashing, and they should flash one at a time, and then we can move on to some other settings. All right, and so if I scroll back up here a little bit, over here on the left-hand side, I'm going to turn on brake on stop. Now the other thing we need to do is we need to reverse the motors that are spinning backward. If you reverse 2 wires on 2 of the speed controllers, they should be spinning the right direction. If they're not, then we need to come in here and click reversed on the ones that are backward. And on mine, they're actually all backward because I reversed the wrong 2 ESCs. That's okay. Reversed, reversed, reversed. It doesn't matter if they're wrong, if they're spinning the wrong direction, because you can just change the direction in the software here. So there. I clicked on right setup, and now they're all updated. So that's all we need to do in here. So I'm going to go ahead and shut this off, disconnect. And I'm going to get back into Betaflight. I'm going to go ahead and connect to this one. If you're having problems where you plug in your you're plugging your battery and your motors kind of start freaking out a little bit, going zzz, 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 zzz. What you want to do is come over here on your ESC motor features and enable D-Shot 300. You can try 600 if you want, but I know 300 works real well, and 300 will make it so your motors stop doing that, and then it actually will respond correctly to your stick inputs. Here on the ports tab, there's 2 things we want to change. We want to turn on the serial RX for UART1, and for UART3 we want to change the telemetry output to smart port, and then go ahead and click the save and reboot. Here on the configuration page, some of the things we want to change. If you scroll down a little bit, we want to change this yaw degrees to 90. And we have to change that to 90 because we rotated the board a little bit so it's not actually facing forward. Down here on receiver, we want to change this to serial-based receiver. And then if you're using an XSR or something that uses S-Bus, you want to change that to say S-Bus. So if we scroll down here a little bit more, another thing I want to change, I'm going to try this time, is the PID loop frequency. I'm going to set this to 8 kilohertz. So now both of these actually say 8 kilohertz. And down here in the very bottom in the other features, I turned on telemetry and black box is on. If you're not going to use the black box stuff, you can turn it off. In fact, I think I'm going to go ahead and turn it off because I never use it. Save and reboot. Okay, one more thing to tell you real quick. If you're doing races and sometimes you crash and you can't go out on the course and set yourself back up and your quad won't arm. Well, if you're in the situation where you want to be able to arm your quad, arm your quad no matter which direction it's leaning, then you can come in here and you can turn off this accelerometer. Accelerometer is how the quadcopter knows that he's sitting level or not. And I have it turned on right now. You can turn that off, hit save and reboot. And if you come back over to the setup tab, your quadcopter will not move. The little animation won't move because the accelerometer is what's telling that quadcopter how to move. But it'll still work, it'll still fly. But you'll also lose your auto level and your horizon modes. So if you need horizon and auto level, don't turn this accelerometer off because they won't work anymore. But if you're racing in acro mode, then you can turn this off. And like I said, if it's kind of tilted at a 45-degree angle, it'll still go ahead and arm and be able to take off. Also, if you're stuck upside down in a tree, you can turn it on. You can still arm because your accelerometer is off. And you can try to play with the throttle and try to get the brake loose and fall out of the tree. Well, anyway, you can decide if you need accelerometer on or not, but I'm going to leave mine on for now. Over here in the modes tab, I went ahead and I turned on the angle mode and the horizon mode and the beeper. And I have the angle mode set to auxiliary 1 and the horizon set to auxiliary 1. And I have the beeper set to auxiliary 2. And right here, this tells you where they're at right now, where the switches are. Now, if you don't have 2 auxiliary channels set up, it's not going to do any good to have these, but you should have at least one set up to be able to change it from angle mode to horizon mode. Angle mode keeps you from actually rolling over and doing flips and only lets the quad lean about 40 or 45 degrees and it stops you. And the horizon mode, and also the angle mode will also, if you let go of the stick, it'll level you back out. Horizon mode does the same thing, where it goes ahead and levels you back out if you let go of the right stick or the pitch and roll stick. And if you crank it all the way to the side though, horizon mode will let you go ahead and flip on over and roll over, and then if you center the stick again, it will take over and try to auto level you back out. So if you want those turned on, you got to have them set up to an auxiliary channel. And then the beeper down here I have on auxiliary 2, so if I flip the switch all the way, the beeper will start beeping and help me find the quad when I crash in the grass. Here on the receiver tab, this is where you need to make sure that your channels are all throwing the correct direction when you move your sticks. If they're not, you probably need to change this channel map. There's usually 2 that usually work. One of them is AETR 1 2 3 4, and the other one is TAER 1 2 3 4. You can just click in here, manually change it, and then hit save, and it should save. Another thing, you're gonna have to go through your settings and set your endpoints so that your throws go down to 1,000, up to 1,000, and center around 1,500. You'll know you have it centered correctly when this animation stops spinning or stops moving. In this case, I don't know why it's moving. I thought I had it centered. Okay, well anyway, if you don't have it centered, then it's going to have a hard time flying, and you don't want that. You want it to just, when you're not playing with the sticks, you want it to sit still. So in this case, I'm going to go ahead, I'm going to see if I can do a little bit of adjusting. Maybe I can. We'll see. Anyway, you want to make it so that this animation, there's pretty much stopped. You don't want that animation to be moving when your sticks aren't moving. If it is, like I said, it's going to have a little bit harder time flying it because it's going to be reading some stick inputs that you're not giving to it. So you need to get this leveled and get this to stop moving by adjusting your endpoints in your transmitter and adjusting your trims to try to get the middle to be right at 1,500. One other thing to note, if you're using D-Shot 300 here, you don't have to calibrate your ESCs. If you're using multi-shot, you do, but D-Shot somehow, with magic, just makes your ESCs just work. So I finished with the programming, and I went ahead and I put the 4 spacers in here in the top plate and the camera holders. Now on these bottom screws, I did use a small drip of the blue thread locker, like this, to help keep those screws in because I rarely ever check the bottom of the quadcopter for loose screws. Probably should do that more often. Up here on the top, however, I did not use any thread locker. I just left them just as they come. And because of the clean wiring, look at how much room there is inside this thing. Now the camera, if I have this receiver here, it's gonna be a little bit forward, so I need to push that back a little bit, and that'll let that camera lean back a little bit more. But this is a pretty clean build for the most part. The only thing you could probably do a little better is to take your receiver and try to turn it around the other way. That shouldn't be too hard to do if you need to clear up a little bit more room. Anyway, next thing to do, since the motors are all spinning in the right direction and the configuration is finished, I'm going to put some of these props on and take a little spin, and hopefully it flies. We'll see. One thing I usually forget to mention is when you put your props on, there's two different kinds. You can see here, this one on the right kind of leans this way, and this one over here kind of leans this way. It kind of up like this and up like this. And basically, if the propeller turns this way, it's going to be lifting the quadcopter into the air. And so one way to remember this is that you need these propellers to turn into the middle. They should both be spinning like this. Like this direction, and they should spin into the middle, and both of them should create lift when they spin this direction. And the same is true up here. They both are going to spin into the middle, so they should be spinning this direction into the middle like this, and that way it will generate lift, and that's the same directions the motors should be spinning. If they're not turned that way, it's going to, as soon as you try to take off, it's either going to just flop over, or something as bad is going to happen because the props are on wrong. And usually, if you're at a flying field with other people, they will laugh at you. So, get your props on right. All right, here at Roaming Park today, we're going to fly this Genius 215. I got it all finished. It's all hooked up. Flying with the 4-cell battery. And these are 5042 props. I don't know. We'll see how they do. And I'm flying my Tyrannus. Here we go. It's a little breezy. Hopefully, everything goes well. And this is 4-cell, so the other one's running like 8 volts. This one's running like 16. So it's a lot more powerful. Oh gosh, yeah. That's awesome. And then these propellers on here are not real aggressive. You can get more aggressive propellers and it'll be even faster. Yeah, this one doesn't have any problems doing hardly anything. To keep the battery from getting destroyed by these screws on the bottom, you need to get a little piece of foam or this little piece of gel stuff. I got this at twistedquads.com. I'll put a link in there for this. It comes in a big piece. You just cut it down to what you need. But you just need something in there to keep the battery off of the screws so it doesn't, so the screws don't tear up your battery. And this stuff's a little bit sticky, so it holds the battery on here just fine. And this is going to be a 2-cell battery that I'm going to fly with now, just to show you that it does fly on 2-cell. These 2600 motors don't mind 2-cell at all. This is a 2-cell battery. That's full throttle, flying away from us. We can flip on 2-cell. It's a little bit slow to recover on 2-cell, but it can do it.
4,